Hi and welcome. In this example, we will do power calculations for different resistors. So the question is, in each of the circuits below, find the unknown value for voltage or current. So here you can see the unknown is V1 with polarity given. Similarly, here we have unknown I2 with the direction of the current given. And here we need to find this V3 in this polarity. And here we need to find I4 in this direction. And the second part is determine the power dissipated in each of these four resistors. So here we have the resistor 8 ohm. Here we have resistor and its value is represented in terms of conductance. So do keep that in mind. Here we have this third resistor with 20 ohms value, and here we have fourth resistor with 25 ohms value. So let's start with the solution. So let's say, and of course here we are going to heavily use the Ohm's law. So let me write it down here. V equals to IR, and let's also write its other forms. I equals to V over R and R equals to V over I. One important step you need to do before solving any circuits problem is to assign one of these conductors as ground, okay? Because voltage is the difference between the potential of two terminals. So if we say one terminal is at 0 volts, then the calculations become much simpler. So let's assign the lower point as 0 volts, and that is represented by this symbol, which is called ground. Now we have said this is 0 volts. All the voltages at other points would be with reference to this voltage. Let's come to the first problem. Here this current source is forcing 1 ampere current in this direction. So now think about this. This is a closed path and there is only one path for the current to flow. So this 1 ampere is flowing upwards, and from here it will come to the right side, and from here through the resistor it will be flowing downwards. Okay, so for a moment let's forget about these unknowns and their directions in terms of current and their polarities in terms of voltages. Now this 1 ampere is would be flowing downwards through this resistor. So the current through this resistor would be 1 ampere flowing downwards. And also we know that for resistors the current always flows towards the direction of voltage drop. So if this is the voltage polarity in a resistor, the current would be always flowing, the conventional current would always flow towards the direction of voltage drop. Now we know the direction of current flow. So accordingly, we can say that this has to be positive terminal for this resistor, and this has to be the negative terminal as per this rule. Now we know the value for resistance and we know the value for its current. So can we use Ohm's law to find its voltage? Well, yes. We can simply put the value for current and resistors and the resistance into this equation. So voltage is equal to IR. So voltage for this resistor would be I, which is 1 ampere, times R, which is 8 ohms. So voltage would be 8 volts in this polarity. Now we can compare the polarity we found out and the polarity asked in the question. So here the positive terminal is upwards, and here we have the same positive terminal. So we can say that V1 equals to 8 volt. Now for the second case, since this is 0 volts and this voltage source is enforcing a difference of 50 volts between the terminals of this voltage source. So which means that the positive terminal of this voltage source is at 50 volts higher than the negative terminal. And since the negative terminal is at 0 volts, this positive terminal is going to be exactly 50 volts. And since this is the same conductor, this is also going to be 50 volts all until this resistor. Now this is 0 volts, this is 50 volts, so we know that this is the positive terminal across resistor, this is the negative terminal across resistor. So the voltage across this resistor is 50 volts. We need to find the current. So current, using this formula, I equals to V over R, I equals to V over R. But here we are given this conductance. So instead of 1 over R, we can write Vg, which is voltage times conductance. So voltage is 50 volts, 50 volts times conductance is 0.2 Siemens. And when we multiply that, 50 times 0.2 is 10. And since we are finding current, it is going to be 10 ampere. Using this rule, we know that the current would be flowing in the direction of voltage drop across the resistor. And since the direction of voltage drop is downwards, so this current is flowing downwards. And now we can compare the direction of unknown current and the current we just found. Since these are in the same direction, so we can write that I2 is equal to this current, which is 10 amperes. So I2 equals to 10 amperes. Moving on to the third question, we have, this is 0 volts, of course. Now 1 ampere is flowing downwards. Now this is a closed path for the circuit and there is only one path for the current to flow. So this 1 ampere is flowing, it will come in this direction and then through the resistor it will go upwards, okay? And then it will come here and back to the same terminal, okay? So in this way it is flowing in the anti-clockwise direction. And since we know the direction of conventional current flow through the resistor, we can say that the lower terminal has to be positive, the upper terminal has to be negative, because the current would always flow through a resistor in the direction of voltage drop. Now, what is this voltage? This voltage equals to the current times resistor. Now, what is this current? Well, this 1 ampere, it is the same current which is flowing through this resistor. So 1 ampere times resistance, which is 20 ohms. So 20 ohms, and this voltage is equal to 20 times 1, which is 20 volt. Now, since the polarity of the voltage we found out is opposite to the polarity of the unknown voltage, we can say that V3 is negative V equals to negative 20 volts. And now the last question, here this is the voltage source. So if this is 0 volts and it is connected to the negative terminal, then the positive terminal has to be at 50 volts. 50 volts. So this is also going to be 50 volts. Since this is 0 volts, this is higher than that by 50 volts. So this terminal is positive, this is negative. And also we know that through the resistor, the current would always flow in the direction of voltage drop. So the conventional current would be flowing downwards. And so far, we are totally neglecting this direction of current being asked in the question. So what is this current I? Well, I equals to V over R. Now V is 50 volts across the resistor. So 50 volts divided by what is the resistance? It is 25 ohms. So this I equals to 50 over 25, which is 2 ampere flowing downwards. But the question is, what is the I4 flowing upwards? So I4 equals to minus I, which is equal to minus 2 ampere, because the directions of these two currents are opposite. So we compensate that by putting a negative sign here. So let me underline all these answers. The unknown for this question is 8 volts. For this, it is 10 amperes. Here, this is minus 20 volts. And here we have minus 2 amperes. Now let's come to part B. So here we need to find the power dissipated in each resistor. So for a moment, let's forget about this Ohm's law and let's look at the three formulas for power. So we know that power equals to VI, and it is also equal to I square R, and it is also equal to V square over R. Remember the three different forms of the power equation for a resistor. We can use any of these equations to calculate power for these resistors, and all of them would yield the exact same answer. And after solving part A, we have all the unknowns related to resistors. For all the resistors, we know their values, their currents, and their voltages. So we can pick any of these forms. So let's figure these out one by one. For this resistor, P equals to, let's start with the simplest one, P equals to VI. Now, since we know that the resistor is always going to dissipate power, and as per passive sign convention, the dissipated power is positive. So we don't need to worry about the signs of the voltage or the directions of current. Here, we know that the resistor has a positive power because the power is always going to be dissipated in the resistor. So we can simply multiply this voltage with current. The voltage is 8 volt times 1 ampere. 1 ampere. So power is going to be 8 times 1, which is 8 watt. For the second case, we know the voltage is 50 volts across this resistor and we know its current. So we can use this formula. So voltage is 50 and current is 10. So it is 500. But let's also show you that the different forms will yield the same answer. So let's write this as I square R as well. So I square is 10 squared, which is 100, times R, which is this is conductance 0.2 Siemens. So the resistance value equivalent to that would be 5 ohms. So if I write 5 and multiply, we still get the same result, 500 watt, 500 watt. Now for the third case, let's use V square over R, where voltage is minus 20 volts. So minus 20 squared over 20 ohms. So 20 and 20 squared cancelled. So power is going to be 20 watt. And for the last scenario, the voltage across the resistance is 50 volt. So power is equal to 50 volt times 2 ampere. So power is going to be 50 times 2, which is 100 watt. So let me underline the results for our part B. Here we have power dissipated as 8 watts. Here the power is 500 watts. Here it is 20 watts. And for the last case, we have power dissipated equal to 100 watts. So in this way, we can find the unknown values for voltage and current for simple resistive circuits, and similarly we can find the power dissipated in resistors using different power relationships. So I hope that was useful. Thank you for watching, and I will see you in the next lesson.